In this chapter, we are going to learn about electromagnetic waves. Okay, in the previous chapter, you have learned about the properties of waves. Okay, so let's pause the video for some time and try to work on these questions. Okay, now let me go through the answers. Which of the following statement is true for transverse wave? Okay, let's look at A. An example of transverse wave is sound wave. That is wrong because sound waves are longitudinal wave. They are not transverse wave. The only longitudinal wave that you learn are sound wave. Next, the direction of vibration is parallel to the direction of travel of the wave. That is wrong. Okay, parallels is for longitudinal wave, but for transverse wave, the direction of vibration will be perpendicular. Okay, for transverse. They are not parallel. Okay, next one. For C, the speed of the transverse wave changes when the wave travels through a different medium. This is correct. When I travel through a different medium, that means I go from solid to liquid, or solid to gas, or gas to liquid, gas to solid, etc. The speed changes. Okay, the speed will change. The speed of the wave depends on the medium in which the wave is in. Okay, next one. So this one is wrong. The frequency of the wave depends on the medium. No, the frequency is dependent on the source. So if I have the same type of wave or the same source, I will have the same frequency. But the speed of the wave is dependent on the medium, the type of medium, whether it's a solid, a liquid, or a gas. Okay, so the correct answer for this is C. Okay, next example. You may pause for a short while to think. Okay, let's go through. An example of transverse wave is light. The answer is true. Okay, light belongs to a transverse wave. The only longitudinal wave learned is sound. The rest of the other wave, most of the time, they are transverse wave. Okay, then let you watch a short video to show you what are electromagnetic waves about, and then we are going to learn some of the properties of electromagnetic wave in this video. Okay, let's play the video.
Electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin, kill bacteria and viruses. Used to detect forgery, that is ultraviolet. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs. That is the work of X-rays. Kill cancer cells and sterilize dangerous gamma rays. Do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
Okay, so just now you have watched the video about electromagnetic waves. Okay, let's come back to our PowerPoint slides. Okay, you can read through this yourself. Okay, as seen from the video, okay, the electromagnetic waves are actually a spectrum of different waves. Okay, these waves differs in terms of their wavelength and frequency. Okay, and they are arranged in order of their frequency or wavelength. Okay, so if you can open up in your textbook, you will be able to see this table. Okay, and from the song, you should also know, okay, we have a few waves like radio waves, microwaves, infrared rays, visible light, ultraviolet, X-rays, and gamma rays. Okay, you are required to memorize this entire list. So how do we memorize this? We try to think of a mnemonic in order to remember it. So you can create your own or you can memorize my mnemonic. Okay, so okay, based on this picture, I'll come back to this picture later on. Okay, so there are 7 waves in the spectrum of the electromagnetic wave. The 7 waves are radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. So how do I remember them in order? Okay, my mnemonic is real men in Vietnam use extra guards. Okay, so that will be in this order. Real men in Vietnam use extra guards. Okay, if you don't like this order, you can remember it in the other way. Okay, which is Generation X use violence in my room. I repeat, Generation X use violence in my room. Okay, so either one of these is fine as long as the order is correct. Okay, and with that, you also need to know that why are they arranged in this specific way? It's because their wavelength and frequency is different. Okay, radio wave, just now you can see from the video, radio wave has very high wavelength. They're very, very high wavelength. Okay, but when they have very high wavelength, they will have very low frequency. Okay, because all of them will travel at the speed of light, which is 3 times 10 to the power 8 meters per second in a vacuum. Okay, so V equals to F lambda when the lambda is high, the wavelength is high, the frequency will be low. Okay, so we say that the frequency increases downwards. That means gamma rays have the highest frequency, which also means it has the most energy. Okay, but then it has the lowest wavelength. That means it can only travel a very, very short distance. The wavelength is so small. Okay, so I come back to here. You can see from this, how do I represent it in terms of wave? It's over here, this wave thing. Okay, you can see that the wavelength is much longer. Okay, the wavelength is from this point to this point. Okay, the wavelength here for radio wave is much longer as compared to here, okay, which is for gamma rays. Okay, so radio wave is very long, gamma rays is very short. Okay, so the wavelength is longest for radio wave. Radio wave can travel a very, very far distance. Okay, but then the frequency will be opposite because of V equals to F lambda. Based on V equals to F lambda, when the wavelength increase, the frequency must decrease because all of them have the same speed. Okay, so the frequency will be opposite. Radio waves have very little frequency, but gamma rays have very high frequency. Just take note that frequency is actually linked to energy. Okay, frequency is linked to energy. So we say that this gamma rays, okay, have very high frequency, so they have very high energy. Okay, very high energy, very dangerous. But radio wave has very low energy because it has very low frequency. Okay, so something with very high energy, we cannot expect it to travel very far. Otherwise, a lot of us will die. Okay, but then radio wave is all around us. It can travel a very, very long distance. It's used for transmission of data. Okay, over very long distance. All around us, we are surrounded by radio wave. But good thing is the energy is very low. So it doesn't cause much harm to us. Okay. Okay, then other than this mnemonics about real men in Vietnam uses extra gun, you also need to know that in number 4, the visible light, okay, you also need to know the orders of the color. We know that visible light is made of rainbow colors. Okay, so you need to know the rainbow colors in order. Okay, so I have another mnemonics for visible light, which is over here. Okay, so under the visible light, okay, you need to know visible light is made of red, orange, yellow, green, blue, indigo, violet, 7 colors of the rainbow. Okay, you need to know the order, and you need to know red is nearer to the side of infrared. Okay, and violet, which is the last one, is nearer to the side of ultraviolet. Okay, so how do I remember it? I go by the mnemonics of Roy Goes Boating in Vietnam. Okay, so instead of real man in Vietnam uses extra guns. Roy Goes Boating in Vietnam. Okay, so I'm using all in Vietnam to help you. Okay, Roy Goes Boating in Vietnam. Again, okay, so red is nearer to infrared. Okay, violet is nearer to ultraviolet. So within this visible light, we have the 7 different colors. They also have different wavelength. Okay, we say that red has the longest wavelength, but the lowest frequency, while violet has higher frequency, but shorter wavelength. Okay, so it's in order. Okay, next, you may try to scan this QR code, which will bring you to a word wall, and then you can try to put in your labels for the EM spectrum. Okay, next, so we learn about what is the EM spectrum about. It consists of 7 different types of waves. Okay, and these 7 different types of waves are arranged in order of their wavelength or frequency. Okay, the higher the frequency, the shorter the wavelength, and vice versa. Okay, and you need to know the order. Okay, now we move on into the properties of EM waves. Okay, you need to know that there are some properties that all the 7 waves inside the EM spectrum will obey. Okay, the first one is that all the EM waves, the 7 of them, gamma ray, X-ray, all those, they are all transverse wave. Okay, none of them are longitudinal. They are all transverse. Okay, all of them do not carry any charges with them. They are not positive charged. They are not negatively charged. They are just neutral waves. Okay, and then next, you should know that they all travels with the same speed, 3 times 10 to the power 8 meters per second in vacuum. Okay, when it goes into another medium, they will have a slightly different speed. Okay, it will either slow down or speed up. Okay, but in vacuum or in air, we say that the speed is generally all the same, 3 times 10 to the power 8 meters per second. Okay, and light belongs to visible light, belongs to the spectrum. And you should know light travels at the speed of 3 times 10 to the power 8 meters per second in vacuum. Next, all of them will also obey the wave equation, which you have learned previously, V equals to F lambda. So as the frequency increases, the wavelength decreases to maintain the same speed of 3 times 10 to the power 8. Okay, so the next one is an illustration of how V equals to F lambda works. We say that whenever a wave travels from one medium to another medium, okay, the speed will change and the wavelength will change. When the speed changes, the wavelength changes, but the frequency remains the same as long as the source remains the same. That means I'm still using the same type of wave, or I didn't change the frequency of vibration of the wave. Okay, the one that is producing the wave, the source, remains the same. The frequency will always be the same. So when I go into different medium, the speed changes, the wavelength changes. Okay, and then next, all waves will undergo reflection and refraction, which we'll learn more in that in the chapter on light. Okay, all of them will transfer, like in general, all waves transfers energy without transferring matter. Okay, and then you need to know that within the spectrum, there are some waves that are ionizing waves. Basically, your gamma rays and your X-rays, they are ionizing. Okay, so ionizing waves has very, very high frequency. Okay, they have high frequency and therefore they have high energy. So what does it mean by ionizing? They are able to knock out electrons, okay, so that from atoms and molecules, so that once your atom and molecules loses the electrons, they will become ions. Okay, they create these ions, and these ions can be very harmful to our body because they disrupt the cell functions and might even cause the cell to die. So ionizing waves are dangerous, basically gamma and X-ray, which has very high frequency and high energy. Okay, and in general, bodies that are hotter, higher temperature will emit more waves. Okay, will emit more waves than body of lower temperature. Okay, let's go on to what example. You can read and pause. Okay, let's go through the answer. Okay, so you have a GPS. They give you the distance, 20,000 kilometers. And then they say that it's communicated using 1.5 gigahertz. Okay, I hope you still remember your prefix giga means 10 to the power of 9. Okay, times 10 to the power of 9. And this is in kilometers. Kilometers, you should know, times 10 to the power of 3 for kilometers. Okay, so they ask, what is the shortest time? Okay, so how do I solve this? I want the time taken for it to travel. So I need to find what? I need to find the speed, okay? Because I give you the distance, which is 20,000 kilometers. That is the distance. I need to find the speed. Okay, so you should know that electromagnetic wave, all of them travel at a speed of 3 times 10 to the power 8. Okay, so time equals to distance over speed. Okay, so the distance is 20,000 times 10 to the power of 3. Okay, this is 20,000 times 10 to the power of 3 divided by the speed, which is 3 times 10 to the power 8. Okay, and then you get a timing to travel. Okay, next one. Which part of the EM spectrum does the wave belongs to? If you look up at the front over here, okay, 1.5 gigahertz, okay, which is 10 to the power of gigahertz. Giga, 10 to the power of 9. Okay, you should be able to get it is somewhere in the microwave region, 10 to the power of 9. It's over here. Okay, so it's in the microwave region. Okay. Back to my question. Okay, so 1.5 times 10 to the power 9 is in the microwave. So it belongs to the microwave section. Next question. Okay, pause. Okay, let's go through. Okay, so you have a wave that travels from one medium into another medium. Okay, so the wavelength will increase. Remember when I say when you move from one medium to another, the speed will change. It will either speed up or slow down. And when the speed changes, the wavelength also changes. So you need to use the formula V equals to F lambda. Okay, as you can see, using V equals to F lambda, the frequency doesn't change because I'm still using the same wave. I never changed the electromagnetic wave. The source is the same. The frequency does not change, but the wavelength increases from 5 to 6. Okay, the wavelength increases from 5 to 6. So when the wavelength increases, okay, the frequency remains the same. The speed will also increase. So the speed has increased. Okay, part B, what is the ratio of the speed in the second medium to that in the first medium? So in the second medium, my wavelength is 6 mm, and in the first medium, my wavelength is 5 mm. Okay, so you know based on the formula V equals to F lambda, okay, F is the same, so the speed is actually directly proportionate to the wavelength. That is because frequency remains the same. So if I want ratio of second medium to the first medium, I will just take 6 divided by 5. 6 to 5. That is the ratio. Okay, because in the second medium is 6, and then in the first medium is 5 mm. Next one, question number 2 should be easy. Arrange in order of increasing frequency. Okay, increasing frequency. You should know that the highest frequency is the most dangerous wave. Highest amount of energy is the gamma rays. Okay, and then if you were to use the real man in Vietnam uses extra guns, you should be able to get this order. Radio, micro, infrared, visible light, ultraviolet, X-ray, and then gamma rays. Okay,